Now, I just by show of hands real quick, how many people are done with the second assignment? Very close.
I'm not even close, I'm on number like 9.
Okay. Okay, so sounds like you could use a little time maybe to finish that up. Okay, 'cause I think isn't it's due tonight, I think, isn't it?
Yes.
Okay. So we'll get you down there. I want to get you just thinking about the next stuff. The next assignment, I want to get it on Moodle if I can. It's not quite done. I mean, worst case scenario, I just give it to you out of the book, but I'd rather give it to you on Moodle if possible. So that's going to take me probably, it's not ready this period, though. It'll be ready after school-ish. I mean, maybe even during lunch. But here's what it's going to talk about. The second assignment, correct me if I'm wrong, the second assignment you were solving linear equations and some inequalities. See, we're going to extend that with the third assignment. I'm going to make kind of short, and then we'll push into a fourth assignment that'll be related. But this will be a pretty short one. You can extend that into the idea of solving compound inequalities, and also looking maybe at the graphs of some inequalities, which isn't that big a deal. And if you need to review that stuff a little bit, it's easy to find in the book. Like I say, all the PowerPoints are up there. But I don't want to spend a lot of time in class talking about it unless we absolutely need to. I'd rather you just kind of work through this and get a chance to actually do more math. So here's the kind of thing we're going to look at. Let's try solving, how about this? Let's say whoa, what's going on? Okay, now, how many, let's establish them here. How many inequalities are there in this statement I just made? 2. Okay, this is what we call a compound inequality. Now in math, as in regular language, compound means more than one, right? So we got 2 inequalities kind of mashed together into one statement here. This may not seem like a big deal, but it is. I want you to take a second with just maybe one partner, how about the partner next to you, and see if you two can establish, how you would say that compound inequality with words. And I want it to be perfect. Okay, so take a second. All right. Oops. Okay, more.
Sorry, I'm getting my water bottle.
All right, so let's say break table. These guys use for volunteering you. How do you, somebody from your table here, how do we say that properly? Let's give it a.
Delaney said it front and back.
Anybody? I'll throw it out. Anybody? Yes, ma'am.
That you have to figure out the variable that will match both sides of the equation.
Okay.
Oh,
Yep.
I thought you just wanted to say.
I do. I just want you to say that statement.
Oh.
Okay.
I'll try.
Okay, here we go. Delaney's going to give us a try. We won't laugh at her if she's wrong.
Okay. -3 is less than or equal to -2x plus 1, which is less than, which is less than 5.
Okay, that's a good start. It's true. What she said is true, but technically we want to say this a little, and you probably don't remember this. This has been, in fact, you guys probably haven't maybe even ever spent a lot of time talking about how to say this correctly. Yeah, now I need your attention up here. This is a big class. I don't need you drifting off. Everybody kind of turn around, face the front here. Okay, here's how we want to do this. Anybody want to amend that, what Delaney offered? It's a good start. Yes?
Would be -2x plus 1 is greater than or equal to -3, but also less than 5.
So close. So close. There's just one slight change there, but it's an important one. Now let me repeat that. I'm going to make one change. See if you can tell where I made a change. We would say -2x plus 1 is greater than or equal to negative 3, so far so good, and less than 5. And is a really important word there, because this is what we call, the fancy math word, the 10-cent word for this whole thing, this is what we call a disjunctive inequality. But really, disjunctive, we don't usually say that. Instead, we just say disjunctive means and. It's an and inequality. But it's important for us to note here that it's an and inequality because that's distinct and different from an or inequality, which we'll look at next. Okay? And we want to use the word and. So here's the rule. So you don't sound like a doofus when you go to college and you're saying these compound inequalities, because you don't. You always start when you're dealing with a compound inequality that looks like this, where I've got two inequality signs mashed into one statement. You always start in the middle. You start in the middle with the variable. You always start with the variable, and you say whichever expression starts with the variable, so negative 2x plus 1 is, start on the left, greater than or equal to negative 3, and less than 5. Okay, so it's pinching the value of this statement in between these two endpoints, isn't it?
Yes.
Whatever negative 2x plus 1 is, and we've got to do some algebraic magic to isolate x, but whatever that's equal to, it's got to be that expression is greater than the left endpoint of negative 3, greater than or equal to, greater than or equal to negative 3, and the right endpoint of 5 is less than that. Yes, ma'am?
So you're saying you have to find one answer and then see if it works for the other side?
Well, we're going to, now, like we always do, when we're, like we talked about, I can't remember, yesterday, I think the day before with you guys. Like we talked about the day before yesterday, when we are solving something, we're finding a solution of, in this case, a compound inequality. What that always means is we're finding the value, or in this case, values, of the variable x that satisfy the original compound inequality. We have to find all the values of x that make this work. And in algebra, the way we always do that is by isolating the x. Okay? Now, the steps we go through to isolate x here are going to be precisely the same, or I shouldn't say precisely, they're going to be very similar to the steps we go through when we're solving an equation, with one difference that we'll make a big deal of when we get to it. But what would you do here if I want to get that x by itself in the middle of this compound inequality without even, let's not bog ourselves down with the intricacies of this, just broadly speaking, what are the two things we got to do? First, we have to do what to get the x by itself? Subtract 1, right? Then we have to divide by negative 2, and that will accomplish our goal of getting the x by itself. Now let's do the algebra that's associated with those two steps. So first step we said was subtract 1, right? So if we subtract 1 from everything, okay, in the middle, that's good. In the middle, that's going to get rid of the 1, and we're just going to get a 2x, right? Negative 2x. Good, I was just testing. What do we get over here?
4.
4. What do we get over here?
Negative 4.
What are you for?
Negative 4, right? Okay, remember that subtracting is the same as adding a negative, right? So sometimes, I mean, this is, we're rusty from summer, but negative 3 minus 1 is the very same thing as saying negative 3 plus negative 1. Maybe it's easier to think of that way. Negative 4. The inequality signs, this was a less than or equal to, and that was a greater than, right? Okay, now, next step, now it gets tricky. Now, the next step you told me was to divide everything by negative 2, correct?
Yes.
Okay, so let's do that. Okay, so that's good. It cancels out the negative 2. So we end up with an x in the middle.
Just negative.
4 divided by negative 2.
Oh, it's divided.
Okay.
Subtracting.
Negative 4 divided by negative 2? 2. Okay, here's the tricky part. Here's the part we got to be really careful about. The difference being, the difference from normal equation type algebra being, when we're dealing with inequalities, if we multiply or divide both sides of an inequality by a negative, what do we have to do?
Switch it.
Got to switch the signs. We got to flip the inequality signs. So these inequality signs are going to get flipped around. But we're not done yet. There's one more step with this. That's our answer, but that's really not a good way to write the answer. The reason that's not a good way to write the answer, you can see if we graph the answer, right? If we graph this compound inequality, can anybody tell me, first of all, the graph of an and inequality is qualitatively going to look like what always? The line segment. It's going to look like a single line segment. It's a single interval. Okay, and we'll see that. Now, what's that? So if we're taking all the values of x that are, whoops, did I not flip that?
No, you didn't.
Yeah.
That's how it's gonna be.
Oh, that's right. I got it. Never mind.
For this
Okay,
one, you
never mind.
can
So-
flip these, so-
If x is greater than -2, what does that look like in terms of an inequality? Going to have,
Yeah, this
You know,
is part of
You
it.
would have,
go ahead. I'm going to have open or closed circle. Open circle, because I'm not including -2, right? So does that see what I'm getting at? I'm going to have an open circle at -2, and I'm going to shade in which direction if I want x values greater than, to the right. Okay, so I'm going to go this way, aren't I?
Yeah.
Okay, now let's do the other side. If I want to graph the inequality x is less than or equal to +2, open or closed circle? Closed circle at +2, right?
Yeah.
And I'm going to shade to the left. If I want the values less than 2, I'm going to shade this way, right? And so really all I'm doing is I'm just including all the values in between those endpoints, correct? Okay, that's sort of backwards though, isn't it? Wouldn't it be nice if our compound inequality, if the numbers that formed the upper and lower limits matched up with the endpoints on the graph? You see that this really is backwards? What I want to do somehow is I want to take this whole thing and just twist it around, right? Well, because I'd much rather have 2 is bigger than -2, isn't it? Number lines go from negative to positive, from left to right, and so I'd rather have the 2 on the right side and the -2 on the left side so it matches up with the behavior of a number line, okay? Does that make sense? It really does if you think about it. It's a better way of expressing that interval. So the last step to get a correct answer, this is sort of correct, but in mathematicians are just famously uptight about these things. We want to get it written precisely. So we're going to flip this thing around. That's going to put the -2 down here. It's going to put the +2 up here with the x in the middle. Now what's going to happen to the inequality signs? Yeah, they're going to get, and you almost want to imagine this is written on a piece of glass. That I used one of those dry erase pens and I wrote it on a piece of glass and then I just flipped the glass around, right? I'm going to get, the 2 is going to look backwards, isn't it? But the 2 is going to end up here. The -2 is going to end up down there. This guy right here, when I flip the glass around, it's over here, isn't it? The x is still in the middle. This one's over here, but it's pointing the other direction, right? This one is over here, but it's pointing the other direction. So that's what my answer looks like. Make sense?
Yeah.
oh, yeah.
Okay. All right.
So the smaller number always goes to the
Yeah, we want the lesser of the 2 numbers always be written on the left. Yeah. Okay, last example, and then we'll get you out of here. What about this one? Okay, let's try this one. Okay, so this is also a compound inequality, right? Got 2 inequalities lumped into one. It's easy to see that there are 2 this time because I'm just writing them separately. This is an OR inequality. Now technically we call this one a disjunctive.
What'd you call it?
Conjunctive. So a disjunctive is an OR inequality, conjunctive is an AND inequality. But once again, we'll just think of this as an OR inequality.
That's disjunctive.
here's the rule for an OR inequality. For an OR inequality, we're just gonna do each of them separately. That's it. It's just like two mini absolute value problems, inequality problems. So how do I solve this one? Subtract 1. So that's gonna give me what, a negative 12?
Yeah.
Okay, divide by negative 2. So I get x and 6, and what do I have to do?
Flip the sign.
Gotta flip the sign. Okay, now over here, what do I do? Subtract 1. Divide by 2, do I have to flip it? No.
No.
Because I'm dividing by a positive.
Why do you have to flip it?
Okay.
Like,
Why do you have to flip it if you divide by a negative? Because if you divide or multiply by a negative, this is a hard one to answer, but maybe this will work. If this is 0, right, if I take the number, let's say 2, and I multiply it by 3, now think what we're doing here. That's like taking, let's say we take a line segment starting at 0 with length 2. If I multiply it by 3, aren't I just stretching it by a factor of 3?
Yeah.
Okay. What if I multiply it by negative 3? Then I'm doing two things. I'm stretching it by a factor of 3, but I'm also twisting it or flipping it over the origin, so it's going the other direction. See what I'm saying? And so it's reversing that relationship, if that makes sense.
Yeah.
Okay.
Yeah, that's possible.
Oh, actually, pretty good.
Yeah, we're good.
So there's our answer, right?
Yeah, there it is.
That's it.
Wait, but wouldn't you put it in like you would say, like are those connected or are they not connected?
Okay, good question. Okay, one more thing. I probably should have talked about the graph. Is that what you're asking about?
Yeah.
Graph. So if we graph this guy, if we graph this guy, we're going to have two intervals, aren't we? If we graph this interval over here, we got x is greater than 6. So if that's 0 and this is 6, this is just going to look like that, isn't it? Right?
Yeah.
Value is greater than 6. What about this one over here? If we graph this one in blue,
Oh, it's like the reverse of what the last thing.
yeah, we're just going to have something like that, aren't we?
Also, they're not
Yeah.
the same X.
Okay, right. And now this makes sense, doesn't it? The word or, if you think about this in terms of, let's say, an ant walking on the number line, the words and or, now this may seem like these are just kind of random connections, but I think they're important conceptually to see these things. And I'm looking forward even, like into like calculus and stuff. These are important concepts to feel comfortable with. If we're if an ant is walking on this solution set, he's restricted. Now hold it, we need to have a little talk here. Listen here. This is a big energetic class, and I can already tell this is gonna be an awesome class.
Yeah.
Lots of energy, lots of thinking going on, but I wanna make sure when we're in here, my goal is I want this to be like a really focused, we don't want to be distracted, because this stuff is review, but we're going to get into stuff, I'm going to really move you guys through some material this year. We're going to get into some things that are going to stretch you intellectually a little bit here, and everyone's going to have the opportunity in here to really concentrate and make these neural connections so that they can do this stuff independently. So when we're in here, we have to establish some norms where we're not talking across the tables. And I know there's going to be a huge, people are going to slip and they're here with your buddies sitting in these groups, which is why we might break these things up a little bit. But anyway, there's a tendency to want to just talk across and next to each other, but we got to get in the habit of not doing that when we're in here. And there'll be times when it'll be a little more relaxed. And in the lab, it typically is. But in here, we got to be taking care of business. So I want everybody's complete attention up here, please. Now, when an ant is walking, when he's restricted to walk on this solution set, think about that. That means that the ant is contained between endpoints. He's got these boundaries. He is simultaneously going to be to the right of the left boundary and the left of the right boundary. Does that make sense? So the word and really fits there, doesn't it? Because he is having to fulfill both of these criteria at once. His motion is at the same time restricted by both endpoints. So we need the word and in there. the ant is only gonna be able to walk on x values greater than -2 and less than or equal to 2, right? Both endpoints are working on his motion at the same time. Now, when I move over to this case, with the OR inequality, it's different. When he's walking on the blue part of the solution set, he's only really being restricted by one of the endpoints. Over here, he's only to the left of -4. Over here, he's only to the right of +6. So where is the ant walking? Well, he's either going to be walking on x values less than -4, or he's walking on x values greater than +6. Does that make sense?
Yeah.
And there's a real simple way to remember that. It looks like the oars on a boat. If I'm rowing a boat towards you, and then the oars are sticking out to the side, so there are the oars on the boat. That's what an OR inequality always looks like. Yep.
So like for ORs, they are doing one subject, they're doing one equation at a time, and they're doing 2 equations.
Right, they're doing one with the ORs. With the OR, we're just going to take each of these 2 inequalities and solve them separately.
So it's two different variables for the same variable.
Yeah, two different inequalities that are relating to the same variable. Yep, yes ma'am. No, I mean it'll be in the notes. You'll hear it again and again. I'm not that concerned about it. And in order. Yes, sir.
So this assignment isn't original.
Not yet. Will be real soon. Okay, let's go. 205. I think we're good to go. Yes.